Okay, today we talked about comparing functions. So we're going to compare functions whether they're given to us in a table, a graph, or just as equations. So this says a zebra's main predator is a lion. Lions can run at a speed of 53 feet per second over short distances. The graph shows the speed of a zebra. Compare their speeds. So we know that from this from the paragraph that lions have a rate or a speed of 53 feet per second. So now we're going to look at our table to find out what a zebra can do. So here we have a graph, and these pieces are very important. If you remember, we learned that rate is also slope, and we can use those points to find slope. So if you remember our slope formula, y1 minus y2 over x1 minus x2, and this is not the only way to solve this, but we'll do that this way. So my point up here, I'll call it x1, my other one I'll call y1. My other one I'll call x2 and y2, and then I'll fill those into the equation. So it'll read 236 minus 59 all over 4 minus 1. And 236 minus 59 gives us 177 over 4 minus 1 is 3, and then we can reduce that. 177 divided by 3 is 59. So a zebra runs, on average, I would say, at a speed of 59 feet per second. So now it says compare those speeds. And one way that we can compare them is we can say that a zebra is faster than a lion. In class we talked about how that's why lions pick off the weak and the young, because they can still catch them, or the sick. And we got into conversation about that. Okay, example 2 says the function m equals 140 h. This is important, where m is the miles traveled and h is the hours, represents the speed of the first Japanese high-speed train. The speed of a high-speed train operating today in China is shown in the table. Assume the relationship between the two quantities is linear. Then it says compare the functions y-intercepts and rates of change. So our equation for the Japanese train was m equals 140h, and that was from the other slide. So from here we can find the rate of change. Remember that rate of change is the same as slope, and our slope formula looks like this. So we're looking for those values that are being multiplied. So here it's 140 times h, so you would say our slope or rate of change is 140. And our y-intercept would be what follows, and since we have nothing that follows, then our y-intercept is 0. Now that works for our Japanese train. We now need to look at our train that is running in China. So to find, first of all, our rate, we have to see how these are changing. It looks like we're adding 1 each time. Over here, it looks like we're adding 217 each time. So our rate here would be 217. Our y-intercept, we're going to have to do a little work because our y-intercept is when our x value is 0. So in this case it would be when hours are 0. So I'd say, what would I have to do to get back to 0? Well, I would have to subtract that 1 to get back to 0. So it looks like I would have to subtract 217 to get back here, and that would put us at 0. So our y-intercept would be 0 as well. So it says to compare them. When we compare them, it looks like they have the same y-intercepts, so we would say that the rate of the Chinese train is much faster than the Japanese. train. And remember, that was their first train that was developed, so I'm sure that the rates would be more comparable if we compared rates from China and Japan. Okay, so our last equation says if you ride each train for 5 hours, how far will you travel? So for our Japanese, or let's start with our Japanese train. Remember that our equation was m equals 140h. So we're going to replace our h with 5. And we multiply the 140 times 5 and we get 700. So you could go 700 miles in 5 hours. For the Chinese train, remember that we said our slope was 217 and our y-intercept was 0. So we're going to create an equation using the same variables. They said m equals, and this m are not the same. Our second m here represents miles. So miles equals 217 times hours. So again, we'll go ahead and replace that h with a 5 because it says how far would you travel in 5 hours. So 217 times 5 will give us 1085 or 1,085 miles. Okay, our last example says Lisa's mother needs to rent a truck to move some furniture. The cost to rent a truck from 2 different companies is shown in the table and graph. So it says write a function for each company. To be able to write the function, you have to be able to identify the slope and the intercept. So again, you're going to be looking for our rate here. Looks like it's going up by 10 over here and by 25 here. So our rate for Ron's Rentals would be 25 over 10, which reduces, you can divide both those by 5 to 5 over 2. And then again, you have to find the intercept. The intercept we find by going backwards to 0. So it looks like we would have to subtract 10 from the miles. On the cost, we would have to subtract 25, and it would put you right at 0. So our y-intercept here would be 0. So if we want to rate this, we could say y equals, if you want to use y, it doesn't matter as long as you know y represents the cost. Or you could say c equals for cost. So y equals 5 halves x, and x represents your miles. Or you could have 5 halves m plus 0. To do our other rental truck, we have a rate here that looks like it's going, up by 10, over by 20, so that would give us a rate of 10 over 20, which reduces to 1/2, and you can see right there on the graph, or I can show you this way, right here on the graph, that it starts at 30. So our y-intercept is 30. In class we talked about sometimes when you go to rent something that they give you a service fee to start out with, or a service charge, and so that might be what that $30 is. And then to write the equation in terms of y and x like we did in the last one, you would say y equals 1/2 x plus 30. Okay, so on the last part it says which company should she use to rent for 40 miles. So we're going to use our equation that we had for Ron's Rentals. We had y equals 5 halves x plus 0. So x, remember, represented our miles. So here it says we have 40 miles. So we're going to put 40 in, 5 halves times 40. We don't need to put that plus 0. So y equals 100, so it would cost $100 to rent from Ron's Rental. And this other company, we had the equation y equals 1/2 x plus 30. So we take half of X, which is miles, and we had 40 miles, plus 30. Half of 40 is 20, plus 30 is $50. And so we can see that this other company here, even though it had that fee, would only charge you $50. And so you would definitely choose the second company. And then we also talked about some things why you might want to choose it. It has a much smaller rate, so even over time it's going to cost less, or even over a lot more miles it's going to cost less. Okay, I hope that'll help you. 6.5 Comparing Functions worksheet. Good luck.